Okay, so in this video we're going to build a VLC player controller. So basically what that entails is building a client which interfaces directly with the VLC player, a server that communicates with the client, and a website that communicates with the server. So what that'll look like is you send a command on the website like player pause. The command goes from the website to the server. The server then communicates to the client and tells the client to pause or play the VLC player, and the VLC player will do accordingly. So what that will allow me to do is load up a website on my phone that will basically load these pause, play buttons and the scrubber, volume control, and I can do that on the website, and it will apply those actions on a different computer. So essentially it'll allow me to control a video player on the big TV from my phone. So this is my second take. My first take, unfortunately, I did not properly set up my new microphone, and it's basically just a silent video. So this is how far I got, about 20 minutes in. So what I'm going to do is I'm going to go ahead and delete everything and start over for your benefit. So just completely expunge, destroy it. Just go back to my home. Okay. So here we go, take two. So first thing I want to do is I want to build the directory where the project is going to sit. So VLC controller. In this project, we're going to have the website, the server, and the client. I'm going to go ahead and start with the client. The client, remember, that is what communicates with the VLC player. So let's go ahead and create that, the folder for that project. And then let's initialize a npm project. And let's go ahead and edit this bit. So set license and add my details. Okay. Now let's create a directory called lib where we're going to put like our library files. So the first one we're going to have is vlc.js. So how are we going to control the VLC player? So basically the VLC player comes with a command line interface. So I have VLC player installed. If you want to install it, just VLC video LAN. You can download it, check the binary, install it. So if you have a Mac, it's going to be installed under Applications, VLC. And actually, not sure if many people know this, but the applications are actually basically just folders. But anyways, we're going inside of the folder, and we're just going to go directly to the VLC binary. So when I run that, it actually launches a new instance of the VLC player. So what we're going to go ahead and do is set this path to be an environment variable. So VLC bin will equal this. So now if I run VLC bin, it will go ahead and launch the VLC player. And we need to quit out of it like that. So there we can look at the help page. And there is this command line attribute which is control. So you can specify a control interface. So if we do VLC bin and then do control RC for, I believe, remote control, or maybe I believe CLI also works. So control command line interface, we get a command line interface, and the VLC player has been launched. So if I go ahead and select a media file, paste that. Oop, let's okay, that's invalid command. We need to add. So we're going to add the media. The VLC player will begin to play this. And I can it's quite loud. I can do pause. Media is paused. I can do play. I can seek to a certain time. Pause. I can let's see, seek with no. Let's see, time. Let's actually look at all the commands we can have. So add, we've done that. Play, you also can queue up items, so if you add them, it will add it to the playlist, but we won't be using that. You can seek, pause, set the playback speed. You can get time, which is the time of the video in seconds. You can get length. You can get the volume. Oops. And set the volume. So you basically have a bunch of controls all through the command line interface. So what the client will do is communicate to the VLC player over this command line interface and provide a nice API. So to run programs, we're going to have to use a standard library called child process. So, and let's go ahead and create a class for the actual VLC player. And let's export it. So we want a constructor. And in this constructor, we'll go ahead and pass in the path of the VLC binary and also queue as quit. So close that. So pass in the binary. So yeah, let's just start working with that. Let's also create a index.js inside the directory so we can start testing this. So let's go ahead and require the this class, and let's create an instance. So in the constructor, first thing we want to do is create a new VLC. We might as well create a spin up the VLC player. So we're going to use so this.vlc. We're going to use childProcess.spawn. Now this takes the path of the binary and then array of arguments. So if you remember from this command, we're going to do control, and the second argument is CLI. So we're passing in the VLC binary, which will be this nvar. So this path, and then we're going to run it with this these arguments. So what this will give us is a child process. Now the child process has a few things. So it has the standard error that is a, I believe they call it a stream. So that basically has an event emitter, and it will emit data when there's information on that stream. So standard error we won't care about. And then this will just log to console for now. So if we run the program, it's going to create a new VLC player. And we're going to pass in the VLC binary environment variable. Then it's going to spawn a new VLC player, and it's going to add event handlers for when there's data on standard out and standard error. So basically it looks just like the prompt that got displayed when we ran the actual command because it's printing out the standard out. So there we go. So basically exact same output as if we just put the standard error to def null and just got the standard out. See, exact same thing. So very nice. Let's also add a destroy method, which will tear down the VLC player. So if it's already destroyed, we'll just return. Otherwise, we'll do VLC player kill, and we want to send. When you kill it, you basically send a kill signal to the process. So let's try this one and see if that works. And then we say destroyed is true. Okay, so we'll launch the VLC player. We'll set a timeout for a second. Do VLC destroy and a second. So this should launch the VLC player, and after a second it should close it. So 1. Okay, that did not kill it. So let's try a sig term. One second. Nope. Okay. So let's look at the different kill signals. Okay, that's the default. See signal 7 for list of all available signals. Is that a man page? Man 7. Okay. Oh, there we go. Cool. Yikes. Okay. So these are all the different kill signals you can specify. Which do we want? Oh my gosh. Okay. Sig kill, that's like a very, very big one. Abort program. So let's try, so number 6. So sig abort. One. Okay. So that gives us an error. So maybe there's a better one. So you actually send a floating point signal. Interesting. Cannot be caught or ignored. So sig stop. Stop signal generated from keyboard. Interesting. I don't know much about these signals, but sig stop sounds like an appropriate one. And if it doesn't give us an error, I think that's perfect. So 1 second later, oh, it's jumping up and down. Okay. Yeah, okay. Interesting. Seems to get detached somehow. So let's do it this way. I know for a fact there's a command that we can send over the control channel which will close it. So let's just send that and then do a regular sig kill, which will hang until the process is dead. So we can do VLC standard in. We're going to write Q. So if I run the VLC bin like this, I do Q, it will just quit, no questions asked. So do that, kill it. Okay. So now if we run this, should wait. Okay, perfect. So now let's actually
have some commands we can send it. So let's have add, so add the media, play, pause, seek, get length, all those good things. So let's see, how do I want to do this? I think we'll just, create methods for them all. But we want to have one method they all use, which will be send command. So here we'll have a command and a callback. So remember, we do have some commands that have an output that we want to read. So we might want to say, send the command get length to get the duration of the media. In that case, we want the callback to have the length as one of the arguments. So to do that, we're going to have to read from standard out. So what I'm going to do is I'm going to add a handler in this class, which will be handle standard out, and we'll just have data. So then if there is a if there's a handler defined, then we'll call the handler with the data. And I cast a string here because data is a buffer sometimes because we didn't set the encoding. This will just turn it to like a human readable string, which is what we want. So when we get data, we want to go ahead and pass it off to handled standard out, but we want to bind it to this so that the this here is the same this as here. Hopefully that makes some sense. So when we send a command, we want to set the handler. Okay, so we're going to get data, and we're going to have, let's see, we're going to have the, we're going to have a little buffer here. So standard out buffer. So when we get data, we're just going to add it to the standard data buffer, because this handler here, this on data, does not have any sort of guarantees on how the data will be split up. So what that means is it could call it 5 times, could have one of the calls have that much data, the other one have this much, and so forth. It's not guaranteed to be on all in one call, as far as I know. So in that case, we're just going to buffer it all up, and when we see this little character which says you're on the next command, we'll go ahead and consider the command complete. So up until this point, we assume that it's not going to be spitting out any data, right? Because it only reacts to commands. So all the commands before this have already been processed and the data has been read. So at this point, there will be no emitting of data. When we send a command, we'll be prepared to read that data, and when we get the this little new entry character, we know that we've gotten all the data that we need from that command, and we can go on our way. So let's do that. So handle command, we have this handler. Let's just go ahead and directly write to the VLC player standard in the command plus a new line. So remember, that's how we enter the command, right? We type what we want, we press return, that inserts a new line character and sends it off to the VLC player's logic. So now we send the command, we have the handler set up to read the data. Now we just want to check if the data contains this character. if it does, we can go ahead and, let's see, we probably want to trim off that that character. So it's going to be a new line and then that. So we can go we'll just go ahead and replace it. I'll push it like that. Then here we will go ahead and set the handler to be null, because we know we don't want future commands to be handled by this handler. And then we will call the callback with there'll be no error, because we might want to have errors later, and we want to follow the standard node callback convention. So the first argument is the error, in this case nothing, and then we want to join the buffer and have that be the data. Okay, so let's go ahead and test that out. So let's create a new VLC player, then do VLC.send command. This is kind of a private method because by convention of the underscore, but we're just testing things out. So let's see what happens if we do add and specify the link as we did before. So we have the error and result. Okay, let's test that out. So standard in does not exist. Okay, it's not a function, which it does not. We need to do write, because it's a stream. Oh, I hear something playing, and it's in fact playing. Cool. But interesting, you see this? It has the initial data in here. So when we first launch, we need to have maybe let's just send a command, which is a nothing command. Let's see, how do I do this? So right off the bat, let's read data till we get to that next command character in the standard out, and then let's set up this this handler. So let's wait till we get the first one. So on data, actually, you know what? No, we don't do it like that, because we want this handler, but we're going to set the default handler. So okay, I have an idea. Let's create a method called setHandler. Okay, so setHandler, and then let's have the handler here. So what we're going to do is we're going to set the handler to be the new handler. But like, so I have some intuition here. So we want to be able to spam send command, right? We don't want to have to worry about really anything. But the problem is we want the all the commands to be sequential, and we want to be able to get the output for each command. So we don't want like two commands to be in flight, because we're not sure when one begins, one ends. So actually, this requires a little bit of thinking. Yeah, there's kind of multiple ways to do it. So this is what I'm going to do. I'm going to create a a new library file called reader, and you'll pass in a delimiter. In this case, the delimiter will be this greater than symbol. Whenever we get that greater than symbol, we're going to send all the data that was buffered up until that value. So every time we get a greater than symbol, you'll just send the data chunk that happened before. And that way, we'll basically have two streams. We'll have our command stream, which were the commands we're sending, and then we'll have the output stream, which is the commands that were like all the data we're getting back. So what we can do is every single time that we call send command, what we do is we send the command directly over the standard input, and we queue up the callback. Now, whenever our reader emits an event saying we got a new data block because we got a new line character, we'll just pop off. We'll remove from the queue the last the oldest callback, because that would be the oldest command, and we'll pass in the data for that data block. So hopefully you can visualize that. Let's go ahead and implement it. So let's have reader, and let's see. We want an event emitter, so that is under events, event emitter. So let's see. Module exports. It's going to be a function where we pass in two things: the stream and then the delimiter. So we're going to have to buffer up data. So just create a buffer, which would be an array. So when we get data on the stream, data, we're just going to append to this buffer. But not so fast. We need to check to see if there's a delimiter. So del idx, so the index of the delimiter will be, well, first let's make sure that data is a string. So data index of the delimiter. So if the delimiter is equal to well, greater than -1, let's do that case. So if the delimiter is actually in that data chunk, let's go ahead and push the data before that delimiter. So substring takes in the first index inclusive, and then goes up to, but not including the second index. So it will go up to, but not include the delimiter. So let's push that to our buffer, and then var. Okay, so here we'll actually create the emitter. So, and we'll just say emitter.emit data, which will be the buffer. Okay, so here we'll just push. Well, we'll emit all the data that we have buffered up into the delimiter. So if we don't have that, actually okay. So let's just, while there's a delimiter, we'll get all the buffered data, push it up, and then we'll set our buffer to be the data substring of del index plus 1, del idx plus 1. Okay, so remember it's the first index inclusive, but we do not want this greater than character, so we'll get the next one inclusive. And if you don't specify the second argument, it'll just assume go to the very end. So this is actually data.length, but it's not needed. So we're going to reset the buffer to be that data. Actually, no. We're going to set the buffer to be empty, and we'll set the data just to be that new data. So I'll go over this in just a second. Okay. So what are we doing here? We are getting the data from the stream. We're checking if there is a delimiter. Okay, while there is a delimiter in or data that or to be processed data. So actually this might be good. To process. Okay. So this is the data we haven't processed yet. So while there's a delimiter in this data, we're going to push everything to the buffer up until the delimiter. So now that's processed, right? So after we do that, we've processed everything up until there. So what we have to process next is everything after that. So that makes sense, right? And then we've already processed the stuff, and we know we hit a delimiter, so we can send that over or new emitter. So this is their new data packet, right? Which is the buffer, all the data in the buffer. And then we'll reset our buffer, and we'll go ahead and update or a del index. So because we're not sure if the data that we have to process has another delimiter in it. We don't know, right? So we're basically going to set that so that or to process can be processed if there's a delimiter. And then at the very end of that, we'll just push or to process in here. And that will kind of process it, if you will. So queue it up for the next time we get a delimiter. Okay, so that should serve our purposes, and let's go ahead and return the actual emitter. So when we call this, it will create an emitter and return it, and it will listen for the data on the stream, and it will actually process it and emit data events when we have a chunk of data before a delimiter. So cool. Let's go ahead and actually use that. So we're exporting it. Very good. So reader. So let's go ahead and actually, instead of handling like this, let's do a new reader with this .vlc.standard out. And then we want to pass in, let's see, the delimiter, which in our case is this character. And then on data, we want to do all this stuff. Right, so we have a reader, which will basically get the text segments delimited by this character. And when we get them, it will pass it to or handle chunk. Why not? Cool. So before we do anything, let's see. Okay. So we'll get this, and we're going to go ahead and also we want an array which will be command handlers or command callbacks, or CBs for short. So we're just going to add a dummy one in there because we know when we first launch the program, it's going to send this, which starts out with a new line character. So when we actually handle the chunk, what we're going to do is we're going to do command callbacks shift, and then we're going to call it with the data. So actually, let's just get in the handler, which is this dot shift. So let's actually test that out. So we have an array A with these 4 items. Do a.shift. Should give us 1, and now it's just this stuff. So that looks good. So when we do shift, it will give us the oldest callback, and it will call it. But we want to make sure there is a handler because we don't want to have a null pointer exception. Okay. Cool. So when we send a command, what we do, it's pretty elegant. So we can remove the set handler. What we do is we just add our callback to the command callback queue. And we send the command over. So I think this should work. Let's go ahead and test it. So here we go. We're going to add. Let's get undefined. So undefined is actually the error, this result, because we no longer have the error callback. We probably want it, so let's just do it like that. So null and an empty string. Okay. And let's get rid of this one. Okay. So no VLC player running. So cool. We send the command to add the media. Let's create a little function here, which is log, which takes an error and result, and it just simply logs it. Okay. That way we can just pass that in here. So let's send another command, which will be get length, and log that. So ideally, this will give us the length of the media, which is like 1,000 seconds or something. Okay, that did not work. Let's do some debugging. So let's add this in here. Actually, let's do it like this. A little silly, but what? Will that work? We might need to embed it with square brackets, but let's see. Add a length. Cool. So we also log in what log is being logged. Okay, that's not good. So it's not even doing anything with this. So let's see. I actually want to go like this. So print the JSON object so it actually wraps it in quotes. Let's actually maybe give it some time to load. So let's send it once like that. I'm suspecting that this is the length right here somehow. But let's go ahead and do a timeout and see if that helps, and then we'll try and debug why it's not working now. So when we do that, we'll just send a command. We'll do a second in. Okay, it says length is null, 0. Okay. So let's, in the reader, let's do, let's log when we get data. So to process will be data, right? And then let's log here and say got delimiter to process delimiter index. Let's say buffer. Okay, we actually want to log to process here, not data, because as you can see, data is this buffer. That means really nothing to me. Okay. So let's look at this. We got to process, which is all this junk. Okay, we got delimiter, which is 93. That looks good. So is there actually multiple? So 93, let's see. It's actually go like this. Var string is equal to all that junk. Okay. Oh, yikes. Okay, it actually needs to be double quotes. So we have a string index of it's 93. Okay. So let's get the substring of 93. Oh wow, you see that? There's actually two of them. Huh. So right off the bat, there's two. That's peculiar. Why is that? Okay, so we got delimiter, and then we actually send off all that data, and we got this one again. Then we add. Okay, so yeah, got delimiter, got delimiter. So we should emit twice, but I guess the other one gets eaten up by the non-existent thing. Okay. So let's actually launch the VLC bin again and actually see what happens. So let's get rid of the standard error, so only on standard out. So here I actually only see one of these guys, not two. So let's go ahead and not send any commands whatsoever and see what we get. Oh, you know what? This makes perfect sense. Ah, silly me. Okay, quit all that. This one is handled by the that first handler we added, and the second one is after we do the add command. So yeah, that's expected behavior. So that is absolutely fine. Okay, so let's go back. So that actually seems to be working perfectly. Now the question is, why, when we do it right after each other, are there issues? So let's see. So we basically get to process this guy okay, interesting. So if I just spam this like crazy, what's going to happen? It seems like we have interesting. Instead of having a return character for each one of these, we just get a return and new line. So, that is interesting. So if you spam it, it will just send off of these things and not have this greater than character to indicate that it's ready for new command. So in that case, we should buffer up commands and only send them once the previous command has been completed. And that will get around this this strange issue. So what changes is we need to have a command queue. So let's set a command callback, just commands. Let's see, how do we want to do this? So yeah, we'll have a list of commands, which will initially be empty. And we'll have set handler. So when the handler, let's see, let's have process command, process next command. What this will do is it will get the next command. Let's see, I believe you can do this. Let's see, if we have var a b is equal to 1, 2, a and b. Okay, beautiful. So we're going to unwrap what's in here, and that's going to be two things, the command and the callback. So we also want it to check if it's currently processing. So if processing, and return. Otherwise, we'll say we're currently processing. We'll get the command. We'll write the command. And we'll actually set the handler. So actually, let's set the handle like this. So data, then we'll call the callback. We'll set the handler to be null, and then we will set immediate to do okay. So we can destruct this in a moment. Right now I'm going to try and get it working. So when we send command, we want to add it to the queue of commands, and we want to say process next command. So calling this is perfectly safe because if we're currently processing, it will just not do anything. We'll just return out. Okay. So we send a command, we just add it to our command queue, and we say process the next one. If we're currently processing, we leave. Not processing, we are now, so set it. We get what we should do, so the command and the callback. We define a handler, so once the command is done, we'll get a chunk of data, and we will call the callback with that data. And set ourselves no longer processing, and basically tell the runtime to process the next command, so that if we have another command queued up, it will run. And then after that, all that stuff is set up, we can actually write the command. And I think that looks pretty good. So let's try that again. I might be missing something. Commands shift. Okay, let's stop the Star Wars. Let's see. Cannot read property symbol iterator of undefined. That's a weird one. I'm guessing this is not set properly. Let's first of all just call it just data. Don't think that's a problem though. The problem is this right here. Maybe the unwrapping doesn't work as I imagined. Okay, let's see. Oh, if it's empty, we should not process. If it's processing, or this .commands.length is 0, we can just stop. So that looks pretty cool. So we're playing, as you can see, each one of these got called individually, so it works as expected. So we can remove these logs now. Let's run that again. So got the length. So let's actually delimitate. God, I'm not my vocabulary. Okay, on this with the return and new line. That's pretty weird. Maybe we just trim it before passing it off. Yeah, let's trim. Okay, so what does that look like? We can do that here. So before we hand it off, trim should do the trick. Nice. So the add command still has this guy. So let's actually right off the bat add in a special handler for that. So here we're gonna say we're processing because it's like the startup phase. So processing is gonna be true. And then we set our handler to be nice and simple. So when we get our data, we're just gonna set start processing, go false, and set immediate to actually process next. Simple enough. So that way, this first handler will eat up this bit, the welcome message. Perfect. Okay, so that seems pretty solid. And destroy, we can actually now use send command, but I just wanted to die, so I'm pretty sure that'll just work. So cool. We can now send commands to the VLC player, but it doesn't have the best interface, right? Because we don't want to call send command. We actually want to have methods, and we want to, for instance, cast this to a number. So let's see. The media has to load. I guess it's fine. We'll just have kind of like a raw interface that we can hammer request at, and just pass it directly out to the VLC player. Yeah, that sounds perfectly fine by me. So let's go ahead and do play, and we can pass in the media. All right, let's actually just completely wrap the same language as the VLC player. So add media callback. So literally just set command add. So, you know, cross-site scripting, or not command injection, you know, it's for a home network. I trust the inputs, so yeah, it can happen, but you know, if you're expecting malicious intent, do not do this. Okay, so you know, one way you can do is you have this client, or it gets tricky. You have this client know all the accepted media, and then you make sure that the media it defines is one that's accepted, or you specify the media in some other means like this ID, and then you look up the media and you put it in there. You shouldn't just, because like what we're gonna do is we're gonna actually have the server tell it this is the media you play, and it's probably just gonna directly call this method, which is unsafe, because if you know someone else figures out, oh wow, I can tell the client to run add here. So what you can do is you can specify the media, add a new line character, and then maybe you could somehow get code execution through the VLC player, because I'm sure there's a way to do that. You know, I'm not sure if they protect against that. It might be difficult, but there's probably a way to do it. So anyways, maybe even they could add a remote video file, right, on a different service, and they get your IP address. That's like kind of an easy one, but you know, there's plenty of vectors to attack. So generally, do not do this, but for my purposes, it's perfectly fine. So add play, just put a callback. Okay, add, pause, play, full screen, toggle, what else? Get length. Okay, seek. Again, code execution, danger, don't do. Okay. So that's a nice little interface. So what I'm going to do now is I'm just going to launch Node, and I'm going to do that, create a new VLC player, send the command to, oh, I should have used the actual, let's do vlc.destroy. Oh, I need the VLC bin. Okay, new VLC player. Okay, now I'm going to use VLC add. So I'm going to add that media. I'll log. Okay. So now we are playing, I believe. Yes, we are. Now I'm going to specify pause. It paused. I'm going to specify a callback. So let's do play now. Okay, so this error handling actually messed things up. So maybe a good thing to do is if the callback isn't defined, we'll fill it in for you. Okay. So let's go ahead and do the stuff again. Okay, wow, we have an error here. Line 38. Does not like that. Okay, I probably need to, whoa, what happened there? Will like that. It will, okay. So again, let's just play around with it a bit. 0 VLC, VLC add. Let's copy the file. Add VLC. It is playing. Now let's do pause. Play again. Seek. Pause. Now let's try full screen toggle. Ooh, nice. Okay, so it seems we have a nice interface for the VLC player. Okay, I'm happy with that. And destroy. Cool. Okay, so I'm quite pleased. Another thing we might want to do is if, oh here, we can use the error handler now. So if this is destroyed, we're going to do if callback. We'll just go ahead and do callback new error, or let's define the error here. VLC player destroyed. CB error. Throw error. Okay. So if it's been destroyed, we'll have some error handling. Beautiful. So let's see. Also, I want to rename this method toggle full screen toggle to toggle full screen. And that looks like a pretty nice interface. So I'm going to stop there. In a future screencast, we will make a add a WebSocket server to this client so that other services can connect to it and send it to commands. So you can control the VLC player from WebSockets, and then that will allow us to have the server to be a WebSocket client. Well, we'll have the server know about all the different clients that are in the network, and then the server can connect to it and tell it to do stuff like play videos. And then we'll have a website which communicates to the server, so we can have nice controls and a nice pretty interface which controls any TV or any computer that has a client running. So it seems like a good place to stop. Hope you enjoyed. Maybe you learned something. See you next time.